You've heard the chilling phrase, "The black box has been recovered." But what is this mysterious device really? Is it even black? Is it truly indestructible? And how does this small, humble box hold the keys to unlocking aviation's biggest, most heartbreaking mysteries? Welcome to our channel, where today we're uncovering the engineering marvels that make flying the safest way to travel. So, let's get the biggest myth out of the way. Despite its ominous name, the black box isn't black at all. It's painted a bright, almost fluorescent orange, designed to be easily spotted among crash debris. And it's not one box, but two separate devices. First, you have the flight data recorder, or FDR. This is the plane's diary, meticulously logging thousands of technical details every second, things like altitude, airspeed, engine performance, and control positions. Next to it is the cockpit voice recorder, the CVR. This device is the silent witness, capturing every word spoken, every alarm that sounds, and every faint background noise within the cockpit. Together, they create a complete picture of a flight's final moments. When tragedy strikes and a plane goes down, these boxes become the most vital tools for investigators. They are the storytellers. They reveal exactly what went wrong, whether it was a catastrophic mechanical failure, a split-second human error, or an overwhelming environmental challenge like a sudden storm. Each piece of data, each recorded word, helps experts understand the sequence of events that led to the incident. Because of the lessons learned from black boxes of the past, countless safety improvements have been made. In a very real way, every safe flight you take today is built upon the silent testimony of these incredible devices. Now you might be wondering, how do these boxes survive a plane crash? Well, they are engineered to endure the unthinkable. A black box is built to withstand extreme temperatures, enduring over 1100 degrees Celsius, hotter than most volcanic lava, for a full hour. It can survive the crushing pressure of the deep sea, down to 20,000 feet below the surface. And it's designed to handle immense impact shocks, up to 3,400 times the force of gravity. To achieve this, each memory unit is encased in multiple layers of protection, typically titanium or stainless steel, wrapped in high-tech insulation that shields it from fire, impact, and water. They are the ultimate survivors. But finding them is another story. After a crash, especially in the ocean, a black box activates an underwater locator beacon. This beacon sends out an ultrasonic ping once per second. However, its battery has a limited life. It only pings for about 30 days. This sets off a frantic race against time for recovery teams. They must battle the vastness of the ocean, deep-sea currents, and rugged underwater terrain to locate that faint signal before it fades into silence forever. Every day that passes makes the search exponentially harder, turning the mission into a high-stakes countdown. Many people believe black boxes are completely indestructible, but that's a myth. While they are incredibly tough, they have their limits. The extreme pressures found in the deepest parts of the ocean can compromise their seals, and a prolonged, intense fire can eventually penetrate their defenses and corrupt the precious data inside. Because of this, engineers are constantly innovating. The next frontier in this technology is the idea of deployable recorders, devices that would automatically eject from the aircraft during a crash, equipped with their own GPS and floating capabilities, making them much easier and faster to find. Once a black box is recovered, the real work begins. It's transported to a high-security lab where a team of specialists carefully extracts the data. For the flight data recorder, they download the digital files and use specialized software to create a detailed, second-by-second animation of the flight's final moments. For the cockpit voice recorder, they listen intently to the audio, filtering out background noise to decipher the crew's last conversations and the sounds of the aircraft. It's like solving a complex forensic puzzle, where every piece of information is a clue that helps tell the truth when there are no human witnesses left to speak. The real-world impact of these devices is immeasurable. The story of aviation safety is written in the data pulled from black boxes. In the case of Air France 447, which crashed into the Atlantic, the recorders were recovered from the ocean floor after 2 long years. They revealed a sequence of pilot errors and equipment malfunctions that led to new training protocols for pilots worldwide. Conversely, The tragic mystery of Malaysia Airlines MH370 is defined by the absence of its black boxes, leaving the world with questions that may never be answered. Each recovery, and even each failure to recover, pushes the industry to create safer planes and better procedures. So, the black box is so much more than just a piece of recording equipment. It is the voice of the aircraft, a final testament speaking for those who no longer can. It stands as a powerful symbol of resilience, a testament to human ingenuity, and our relentless pursuit of truth and safety in the face of tragedy. It ensures that every flight has a story to tell, and that we are always listening, always learning, and always striving to make the skies safer for everyone. Thank you so much for joining us on this journey. If you are fascinated by the hidden technologies and untold stories of our world, make sure to hit that subscribe button and join the Sheer Knowledge TV family. We have so much more to explore together. See you in the next video.